shall be talking about a very important topic in physics, which is linear momentum. We shall be looking at linear momentum. And there are different aspects of these topics to be considered. But for this section, which is lesson 1, we shall be looking at momentum itself. Thereafter, we shall be talking about impulse. Thereafter, we shall be talking about conservation of momentum. And lastly, we shall be talking about perfectly inelastic collision. These are the aspects we'll be looking under series 1. So without wasting time, let's look at what we need to know under these aspects. First thing first, for momentum, the unit for momentum is kilogram meter per second or Newton second. Any of these units can be used with what? Momentum. And the formula, the main formula for momentum is mass times velocity. That is the main formula for what? Momentum. Now what about impulse? The unit for impulse, the first and most important unit for impulse is Newton second, or you can also use kilogram meter per second. Now what are the formulas you can use to get your impulse? Impulse symbolized by J, while momentum symbolized by what? P. Observe those differences. Impulse is equals to force times time. This will give you the impulse. Or mass times change in velocity. Observe that it's not just velocity, but what? Change in velocity. M times V is for momentum, but M times change in V is for what? Impulse. And that's why you define impulse as what? The change in momentum. The change in what? In momentum. This is the reason why. Now another formula you can use to get your impulse is what? M in bracket final velocity minus initial velocity. And this is simply an expansion of this formula. Now what S? If you are given two momentum, let's say they said a body, the momentum of a body increased from 10 kilogram meter per second to 20 kilogram meter per to 22 kilogram meter per second. What is the impulse? It's simply 22 minus 10. That's why the formula here is what? Change in momentum. And the answer is what? 12 Newton second. That will give you the impulse. So another formula for impulse, therefore, is what? Change in momentum. If you expatiate this, you will have final momentum minus initial momentum. These are all the formulas you need to know under what? Impulse. So now you know this. Let's quickly look at conservation of what? Momentum. And this is a theory simply stating that what? The total momentum before collision is equivalent to the total momentum after collision. That is to say, there is conservation of momentum before and after collision. And that brings us to the formula you have here, where U standing for what? The initial velocities. And the VV you have here standing for the what? The final velocities. So for the first body and the second body, the momentum of the first body added to the momentum of the second body initially, UU, is equals to the momentum of the first body added to the momentum of the second body after collision. When you sum it up, it should be equivalent to what? The summation of the momentum of the two bodies before collision. And this is the formula where you have M1U1 added to M2U2 is equivalent to M1V1 added to M2V2. This is the formula under conservation of momentum. So now we know this. What else should we know? If the body was moving to the right, the velocity should carry a plus sign. But if the body was moving towards the left, the velocity should carry what? A minus sign. These are all you need to know under conservation of momentum. You will get to understand this better when you try more practical questions under this topic. So what else? Perfectly inelastic collision. This is basically under collision, and this is the most asked aspect of collision in any exam, be it JAM, POSTUTME, or school exam. This is the part of the topic called collision they like asking. It's called perfectly inelastic collision. And the main formula here is M1U1 added to M2U2 equivalent to what? M1 plus M2 times what? V, where V is what? The common velocity. Now, because in most cases, the M2, that is the second body, you see something like they say, a body at rest, stationary. That is the second body, M2, is what? At rest. And if that is the case here, it means that U2 is what? It's 0. And if U2 is 0 here, 0 times M2 will be what? 0. So what you only have on this side of the equation is what? M1U1. That is why in most textbooks, this is the formula you see for what? Perfectly inelastic collision. So it's not bad, very advisable. You can stick to this, okay? Because all questions align with this. But this is just the full formula, the broad form of the formula for what? Inelastic collision. So I hope these formulas are well explained. So without wasting your time, guys, we'll be taking one or two questions on the topic linear momentum. Let's get down to that now. Alright, here are the questions we are asked to solve under linear momentum. So without wasting time, let's get to them. The first question reads, a ball of mass 5 kg hits a smooth vertical wall with a speed of 2 meters per second and rebounds back with the same speed. Now the question is now, determine the impulse experienced by the ball. Now for questions like this, we'll need a diagram to understand what was being illustrated in the question. So assuming this is the ball was coming in this direction. With what velocity? He said what? 2 meters per second. Is it not? Good. Now ask yourself, is this ball going towards the left or right? Answer is what? Towards the left. Now, like I said in the formulas, whenever something is moving in the left direction, it goes with what sign? A minus sign. Is it not? Good. You will need your sign notations here. You don't just solve with the values only. You will fail it. You will miss it. You will need the signs too. Now, after hitting the wall, what happened to the ball? It rebounds back. Is it not? That is a common scenario experience. Whenever a ball hits a wall, it tends to what? Bounce back. Is it not? So the ball bounced back. They said, watch. They said it rebounds back with the same speed. What is the speed? 2 meters per second. So it rebounds back with what? 2 meters per second. Now if you check, the values are the same. Is it not? So there should be a difference. And that difference should be in their what? In their direction. Is it not? This one is going this way. This one is going this way. Now ask yourself, in what direction did the ball rebound towards? The answer is what? Towards the right. Now because it's going towards the right, it goes with what sign? The plus sign. So this one will be what? Positive. This is a better and more correct way to analyze question specifically under impulse, so you don't miss it. Okay? Now let's deduct all we were given in this question. We're told a ball of mass 5 kg. M is what? 5 kg, and that is the SI unit. Is it not? So there's no need to cover. Alright, sorry for that. Now, which was the initial case? Is it not this? This was the direction it was coming. So this is our U, and this is our what? Our V. So coming and write, U is what? Minus 2 meters per second, and the final, which is V, is what? Plus 2 meters per second. Okay? Like this now. Now we are successfully analyze this. We may not have any use for what? The diagram again. Now ask yourself, they now said, determine the impulse. That is, J is what? Unknown. Is that not? Now, go back to the formulas I gave for impulse and ask yourself, which of the formula has M and at the same time has V, at the same time has U and has J? The answer is J equals M in bracket V minus U. And this is the formula we'll be using for this question. We are asked to find J. So what next? Now you have done this, impute all the values you have into this formula. It will now become equals to, J equals to, because J itself has no value yet. What is the mass? 5 in bracket. What is V, final velocity? Accompanying with the sign is what? Plus 2. Plus 2. So these are you do it. Plus 2. Then what is in the middle? Minus. Then what's the value for what? continue solving. This will now be equals to 5 times, now plus 2 plus 2 is what? 4, positive 4, positive 4, is it not? So this is what we now have. So J will now be equals to what? 5 times 20 is what? 5 times 4 is what? 20. 5 times 4 is what? 20. And we know that the first and most important unit for impulse is what? Newton second. And this is the answer to this question. So whenever the body is moving in two directions from the question, you have to take note of what? The signs. You don't just use it direct, because if I use just the value, what would have happened? If I just use 2 and 2 without considering the direction they were moving, I'd have had 2 minus 2, and 2 minus 2 is what? 0. 0 times 5, 0. I will say the answer is 0, and I've missed it. Because you must consider the what? The direction they were moving. I hope this first question is well analyzed. So let's go to the second question. Solution. So we read this together and solve. It reads, a ball of mass 0.5 kilogram, that's mass, so we come here, right? M equals 0.5 kg, and kilogram is what? Standard unit, so there's no need to convert. What else was given? Moving at 10 meters per second. Remember, this is going to be a collision case. It's a case where two balls collide. So this guy, that 10 meters per second, is the initial speed or initial velocity. So you say U equals what? 10 meters per second. Are you seeing that? Now, mind you, this is one ball and there's still another ball. So let's call this first ball M1 and the speed of the first ball U1. I hope that is understood, because there's still a second ball is going to hit it. Is it not? Good. Now let's move on. They said it collides with another ball of equal mass. That means the second ball, M2, is what? Also 0.5 kilogram. So you come and write M2 is equal to 0.5 kg. This is what you have. Are you seeing that? Good. And they said that the ball was at rest. Are you seeing that? So because the ball was at rest, what formula are we going to use? Is it the first formula under perfectly inelastic or the second formula? The answer is what? The second formula. You can still use the first formula and call your U2 0. You see the same thing, okay? But like I said, in most textbooks, they just go straight to the second formula under perfectly inelastic condition. So let's just go straight to that, okay? Why? Because we saw at rest. You can also use it when you also see stationary. Is it not? Good. Then what else? They said if the ball move off together after impact. Why is it called perfectly inelastic? Because the two bodies tend to stick together and move in one direction. Okay? Both are moving in the same direction. So this one was static. This one was come like this. They hit each other. They stick together. Very importantly, they must stick together and move in the same direction. And that's being described here. Is it not? Good. Then I said if they move off together after impact, together after impact, calculate their common velocity. Like we said, common velocity is v and is what unknown in this question. That is what we are asked to find. Now ask yourself, this is a scenario of perfectly inelastic collision, true or false? The answer is what? True. Now since that is the case, are we going to be making use of the first or the second formula? Based on the parameters we have, the answer is that we'll just go straight and use the what? The second formula. And if I was to recap, it is what? M1U1 equals to bracket M1 plus M2 close bracket times V. And V is the what? The common velocity. So now you have these guys. What next to do is what? Impute all these values into this formula. And it's very easy. So watch out. M1 will be replaced by what? 0.5 times U1 will be replaced by what? 10 equals to bracket. M1 will be replaced by what? 0.5 added to M2 will be replaced by what? 0.5 close bracket. Do we have a value for V? Unknown. So we leave it as what? V. And this is what we have. We are still on it, okay? Watch out. Watch out. 0.5 times 10 is what? 5 equals to 0.5 added to 0.5 is what? 1. So this whole bracket, what do we have finally? 1 times V. Now watch out. 5 will now be number. So in this case, it will be what? V. And if you intertwine this equation, you will have V equals 5. And what do you need for velocity? Meter per second. And this is the value of the common velocity. This is the value of the what? The common velocity. So guys, I hope you clearly now understand how easily question under linear momentum can be solved. So without wasting time, I'll be dropping you guys a question to try your hands on. Let's have the question now. Alright guys, here is the question you are asked to try your hands on. And it reads, a ball of mass 4.2 kilogram moving at 10 meters per second collides with a stationary ball, emphasis on stationary, of mass 2.8 kg. So this is M1, this is M2. And this is the U1 of M1. Is it not good? Then I said, if the two balls sticks together and move in the same direction, okay, after impact, that was the by move together, calculate their common velocity. In this case, we are asked to find V. Do well to try your answer to this question and let me know what you think the answer is in the comment section. Don't forget to share my video with your friends, family, and neighbors. Thanks for watching. I remain Fizademi. See you in my next video.